Okay, 3.6 is using perpendicular and parallel lines. So postulate 10 says, if there's a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So there will be exactly one line through the point parallel to given line. So this would be, ooh, that is not good. This would be the only line that can go through the point that is parallel to L. So if P is not on L, then there exists one line through M such that M is parallel to L. So let's say this is line M, and then I made them parallel. All right, the perpendicular postulate. If there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. There's exactly one line that will go through point P that would meet line L at 90 degrees. That would be perpendicular. All right, theorem 3.11. If two lines are parallel to the same line, then they are parallel to each other. Then they are parallel to each other. So, okay. Let's say, let's see, Q and R, sorry, L is parallel to M, and M is parallel to N. So because L, so okay, let me write that out. So if L is parallel to M and M is parallel to N, then L is parallel to N. Right. And if two lines are perpendicular to the same line, then they are parallel to each other. Perfect. So because L and M are both perpendicular to N, therefore they must be perpendicular to each other. All right. So example 1, find the value of x that makes AB parallel to line CD. Okay, in order for them to be parallel, let's see. So I have a transversal, I have a line, and if in order for these two to be parallel to each other, that means if line CD is perpendicular to that transversal, then this must also be perpendicular. So that would mean the angle 2x plus 2 must be 90, because if these two lines are both perpendicular, right, they meet the transversal at a 90-degree angle. If they're both perpendicular to that same line, then they will be parallel to each other. All right, divide by 2, and we get x is equal to 44. This value of x would make them parallel to each other. All right, perfect. Let's continue on. Find the value of x so that D, line D is parallel to line E. Okay, so these must be, because line D is perpendicular to that transversal, line E must also be perpendicular in order for them to be parallel to each other. So these are a little like the arrows, parallel. So that means 5x plus 10 must equal 90. Go ahead and subtract 10 from both sides and divide by 5. So x is going to be 16. All right, let's evaluate squares and square roots. So once again, we have negative of 4 squared, so it's negative of, let's see, 4 squared is 16, minus negative 7 squared is 49, so negative 16 minus 49 is negative 65. So where your parentheses are, right, because there's parentheses, we're going to square the negative, versus here there's no parentheses, so you square and then you put the negative out front. All right, I have 10 squared minus the square root of 8 squared, so that is 100 minus 8. The square and the square root go away, so this is just going to be 92. Continue on. We have negative 6 squared, which is 36, and the square root of 144 is 12, so you add that together and you get 48. Okay, so I want to, so I cancel. Negative 5 plus 13 is going to be 8. All right, this one's a little more tricky. So simplify under the radical first. Negative 3 squared is 9. 4 squared is 16. Add them together, you get 25, and the square root will be 5. Here we have 50, and then 1 squared is just 1, so 50 minus 1 is 49. The square root of 49 is 7. Alright, so ways to show that two lines are parallel. Right, the corresponding angles converse, you're literally, these are going to be equal. As long as those angles are equal, then the two lines are parallel. Here, as long as the two alternate interior angles are equal, then the lines will be parallel. Once again, as long as the alternate interior angles, exterior angles are equal, then it will show that the two lines are parallel, right? Here's a little different. Notice that they're adding to 180. In order to have same side, they have to sum to 180 in order to prove that the two lines would be parallel. And then, let's see, another way to show two lines are parallel is if you show that, okay, these two are parallel, these two are parallel, so therefore that first one must be parallel with the third. That's theorem 3.11. And lastly, if we have two lines that are perpendicular to the same line, that means they must be parallel to each other. So that is it for this lesson and this chapter.